Hello everyone, this session I'll be discussing mixed problems on permutation and combination. Elementary knowledge of permutation and combination you all have. You have used the formula, basic formula of permutation and combination to solve problems from these two topics. Today's class, some questions I'll be discussing where problem can be asked from both permutation and combination. I mean, a problem is there which you have to solve by using the concept of permutation and combination. Let's start with the simplest problem here. In our present problem, we'll be selecting three letters from we'll be selecting three vowels and two consonants from the letter of the word. Then how many words? They may be meaningless or meaningful, it doesn't matter. How many words of 5 letters can be formed by taking 3 vowels and 2 consonants from the letters of the word involute? In involute, if you start writing you need to separate the vowels and the consonants. I, O, U, E. These 4 vowels are there, and consonants I, N, no, not I, N, it will be N, V, L, T. Okay. So the problem is to form word of 5 letters by taking 3 vowels and 2 consonants. You can see all these vowels are distinct. So you don't have to think much. You take 3 vowels from here, out of 4 can be selected in 4C3 ways. And out of these 4 consonants, 2 can be selected in 4C2 ways. So if we go by number of selections, total number of selections going to be 4C3 into 4C2. Total number of selections. But the problem is, you have to form words. You need to arrange those selected 5 letters. They can be arranged in 5 factorial ways. So required number going to be 4C3, that is 4, 4C2, 6 into 5 factorial. So this is 24 into 120. 5 factorial, you know, 120. So this is going to be 2880. Total number of words can be formed by using the letters of the word involute, where we have taken 3 vowels and 2 consonants, equal to 2880. Let us start with another problem. Here the problem is find the number of permutations of the letters of the word forecast and milky, taking 5 at a time, so that 3 letters chosen from the first word and 2 from the second word. Similar problem, but this time 2 words are given over there. You have to select 3 letters from forecast. Forecast, how many are there? How many letters are there? You can count 3, 3, 6 to 8. So out of these 8 letters, you will be selecting 3. How many ways it can be done? Can be done in 8C3 ways. And here in the letter of the word milky also, there are 5 distinct letters, so 2 can be selected in 5C2 ways. This is total number of selections. And you need to form words. So you have to multiply this by 5 factorial. Okay. Just find the value of 8C3, 8, 7, 6 by factorial 3, that is 6, 5 into 4 by 2, again multiplied by 120. So the result is 56 into 10 into 120. So 1200 into 56. So this is going to be 67200. These many number of words can be formed by taking 3 letters from the letter of the word focused and 2 from the letter of the word milky. You have arranged after selection. Okay. So let us start the next problem. So when you are solving a problem like word formation, you need to arrange. Finally, you have to arrange. Problem is a bit difficult here. The question is how many ways 4 letters can be selected and then permuted out of the letters of the word mathematics. It's a common problem. We are taking 4 letters. We can take 5, we can take 6, we can take as many as possible. But here, out of these letters of the word mathematics, we are going to select only 4. As it's a common problem, if you solve it with me, I hope this kind of sums where 6 letters, 7 letters, as many as possible, you are taking and arranging them is possible for you. So let us start counting the total number of letters of the word. Here 3, 3, 6, 3, 11. 11 letters are there. Out of these 11 letters, some are repeated and some are not repeated. Which one is repeated here? The repeated one is A over there. A is repeated, M repeated, E repeated. No, E is not repeated. So let us write the number of. So M is how many there? M. 2 M's are there. We write it first. Then A, how many? 2 A's are there. Done. Then T also 2 T's are there. Then H, only 1 H is there. Okay. Then E also 1 in number. Then I is 1, C is 1, S also 1. Alright. So total 11 letters are there. Now selection of letters of the word mathematics by taking 4 at a time can be done by taking all distinct, maybe 2 M's and 2 distinct, or 2 A's and 2 distinct, maybe 2 T's and 2 distinct. Similarly, there may be case where you are considering 2 M and 2 T's. So depending on this observation, we will be discussing the following cases here. Case 1, when we are going to select all different. All different means how many different letters are there? 3 to 5, 3, 8. Out of these 8 different letters, 4 can be selected. We are writing selection first. Selection can be done in 8C4 ways, and permutation, arrangement of those selected, is going to be 8C4 into 4 factorial. Okay. Now case 2. When we are considering two similar means how many similar letters are there? 3 pairs of similar letters are there. 2 M, 2 A's and 2 T's. Two similar means we will be selecting out of these 3 pairs, 2 pairs. So selection can be done. Selection can be done in 3C2 ways, and their arrangement going to be 3C2. You have selected 4, no? 2 pairs. So their arrangement will be factorial 4, factorial 2 into factorial 2. Here we have considered all the cases 2M, 2A or 2A, 2T or 2T and 2M like this. Two similar means this case. Now let us go for case 3. Case 3 means we will be selecting two similar and two different. Let us consider this case where two similar and two different are there. Two similar, two different means out of these three pairs you will be selecting one. So selection if you do, it is going to be two similar, two different, no? So you select out of three pairs one, and out of how many different are there now? Suppose you have selected two M's, then how many different are there? 1, 2, 3, 4, 5, 6, 7. Okay. Out of these 7, you will be selecting 2. And when you have multiplied the result by 3C1, it means you might have selected 2A and 2 from remaining 7 different letters, or 2 T's and 7 from remaining 2 different. So selection can be done in 3C1 into 7C2 ways, and arrangement. Arrangement can be done in 3C1 into 7C2. 4 you have selected. Out of these 4, 2 are repeated. So 4 factorial by 2 factorial. Okay. So these many ways selection can be done, and arrangement of those selected letters also can be done. Now let us find total number of selections. Total number of selections going to be 8C4 plus 3C2 plus 3C1 into 7C2. You can add all these to get total number of selections, and then total number of arrangements. Total number of arrangements going to be equal to 8C4 into 4 factorial plus 3C2 into 4 factorial by 2 factorial into 2 factorial, this plus 3C1 into 7C2 into 4 factorial by 2 factorial. Okay. Now we evaluate 8C4. So this is factorial 8 by factorial 4, factorial 4. That way factorial 4 if you cancel, it is going to be 70. This is 3. This is 3 into 7C2. That is 42 by 2, that is equal to 21. So number of selections is 63 plus 3, that is 66, and 70. So this is going to be 6, 136. Then number of arrangements how many? This is 70 into 24. This plus 3C2, 3 into 24 by 4. This plus 3 into 21 into 12. So this is 1680 plus 18 plus 63 into 12, that is 756. Now if you add all these 1680, 18 and 756, it is 2454. Okay. Let us consider another problem so that your idea will be very clear. In how many ways 4 letters can be selected and then permuted out of the letters of the word expression. See, here in this session my aim is not to discuss very difficult sum, but the concept of all the concepts of permutation and combination should be learned properly. I have started this series because of the same reason. So let us understand how selection of 4 letters can be done from here. Then you can go for any problem of this kind where 5 or 6 letters can be selected. So to solve this problem, let us write how many E's are there first. You can see there are 2 E's, an X, there is only one X, only one P, only one R, 2 S's are there, and one I, one O, one N. 3, 2, 5, 2, 7, 10. 10 letters are there. Okay? 4 plus 3 plus 3. Now out of these, selection we make the same manner. Case-wise selection will be there. Okay? Selection, we consider the case when two similar are there. So here selection can be done in how many ways? Out of 2 pairs of similar, we can take both of them. So selection 2C2, that is 1, and arrangement going to be this multiplied by 4 factorial by 2 factorial into 2 factorial. So this is nothing but 24 by 4, this is equal to 6. There may be 2 similar, 2 different. So how many ways selections can be done? 2 similar means out of these 2 pairs you take 1 pair, and remaining 3, 4, remaining 7 you select 2. Okay? So selection is going to be 2 into 7C2 is 7 into 6 by 2, that is 21. So it is 42. And their arrangement going to be this 42 multiplied by 4 factorial by 2 factorial, because 2 are repeated over there, so it will be 42 into 12. Okay? This if you multiply, it will be 420 and 84. So it is going to be 504. Now you are taking all 4 different letters are there. How many different letters are there? 3, 3, 6 to 8. Selection can be done in 8C4 ways, and arrangement will be 8C4 into factorial 4, that is equal to 8P4. So 8P4. And this we have calculated before. 8C4 result, we have seen that it is 70. We substitute there. This is 70 and this part going to be 70 into 8P4. 70 into 24, that is 1680. So total number of selections going to be equal to, in the first case it is 6 plus 42 plus 72, 48 plus 70, 8, this is 1180. No, sorry, this is 118 only. So this is going to be 8118. Total number of arrangements this thing going to be equal to, here it is 6 plus 504 plus 1680. So this is 510 plus 1680. So 092190. So I think you have now elementary idea of solving problem where concept of permutation and combination both are required. Selection first and then arrangement. You select required number of pieces and then go for arranging them.